Today we'll be starting our next topic, which is on data and statistics. So the textbook calls it single variable, which means you're collecting one piece of information at a time, and also bivariate statistics. So bivariate means that you're collecting two pieces of information at the same time. So in this first section of this topic, we're looking at collecting, using, and the misuse of statistical data. So we're looking at how we collect it, how statistics can be used properly in the media or in formal professional aspects, and also how sometimes data could be misused. So what we're going to be looking at is identifying different types of data that we can collect and analyzing situations where maybe data has been used properly, or also being able to identify when data has been misused, which is quite important. So by the end of the lesson, you should be able to understand the terminology, so some of the terms that we use when we're talking about collecting and analyzing data, and also categorizing different types of data, and then also evaluating some statistical claims. So firstly, when we're trying to collect data, there's a couple of ways that we can go about it. One of the main ways that we collect data is using surveys. So a survey could be something that you're sent and then you have to fill in and you send back to the company. Could be something that someone on the street asks you to fill in, and then you answer the questions and then you go on your way. It could be something much larger scale, like the census that we've just recently done. So the census is also a type of survey, but everyone needs to fill one out. Now, when we're constructing survey questions, so putting a survey together, it's really important how we put one together so that the person who's answering it knows exactly what they need to say. They know what type of opinion that they need to give. So survey questions should be constructed so that they know what the question's actually asking for exactly. It shouldn't be ambiguous. It should use simple language and also not be worded in a way to deliberately provoke some sort of response. So if a question is written so that you're more likely to say one thing because of the way the question's worded, then there are issues with that sort of survey. We talk about bias in a survey, and that's when the result that we get is not representative of the whole population. So usually surveys are done on certain, like not on every single person, it's on just a small group of people. We want to make sure that this survey is able to give a picture of, what the whole representative population is like, what their opinions are. So for example, if I survey people about their preferred supermarket right outside Coles, I'm not going to be able to get some good data there, because more often than not, most of those people are going to say, Coles is my preferred supermarket. So here's just a couple of questions. These are from your textbook for you to think about. So here's a couple of survey questions, and just for you to consider some of these issues about the questions that have been given. So the first question was, how old are you? So one thing that you need to think about is, what will the answers look like? How would you be displaying these questions? Question 2, how much time did you spend sitting in front of the television or a computer yesterday? Okay, so think about what you did yesterday. Okay, how much time were you in front of the television or computer? So again, what will these answers look like? Okay, what are the possible answers that someone could give for these? And how would you go about displaying this sort of data? Also, will this give us a realistic picture of your normal daily activity? Question 3, some people say that teenagers like you are lazy and spend way too much time sitting around when you should be outside exercising. What do you think of that comment? So again, what do you think these answers will look like? How can you represent these answers? So how can you display it? And is there any way that we could improve that question? So these are just things to think about. So obviously, these questions, there's even though it's simple language, the questions can be quite ambiguous. There's not a lot of scope for knowing exactly what the question's asking for. So just have a bit of a think about those, and maybe just write down a couple of comments about each of those questions. Okay, let's keep going. So statistics are often used by the media. It's used because it's sort of like an official sort of almost like scientific way of backing up their arguments. But sometimes the media, intentionally or unintentionally, will convey misrepresented information to the public. So sometimes it might be just the person who was making the graphs, they weren't very good mathematicians, and so they made some very big errors in their graphs, or how they constructed their axes and things like that. Or it could be intentional as well, where they're trying to provoke a certain an image, a certain reaction out of people. And it's important that you know enough about graphs, how to interpret graphs, how to look at statistics, so that you're not misled either intentionally or unintentionally. So here's just a couple of examples of places where numbers have been used, or graphs, and it hasn't been too good. So determine what type of problems can be seen in these statistics. What interpretations can these cause the viewer to believe? So let's start with this first one here, this pie chart. Now, it is American, so I don't know too much about these people, but if we look at this pie chart, we've got our pie here. I might just change my color, pie. Now, we've got a sector that's 70%, a sector that's 60%, and a sector that's 63%. Now, hopefully you're able to see a very obvious issue here, because if we're talking about a pie chart, all of those probabilities should really be adding up to 100%, not the 193% that this currently has. So one of the issues with this type of graph is that they've actually used an inappropriate graph here. So maybe instead of using a pie chart, they should have been using a column graph. Or maybe there was some other way of representing the data. Maybe the type of information that they have here isn't quite useful. So say, for example, maybe people were able to put in multiple options, and that's why these add up to more than 100%. Maybe it could be that they were looking at different groups of people. So maybe they looked at one group of people and then worked out a percentage for Palin, looked at another survey and then looked at their percentage for Romney, and so on. So there's quite a lot of issues with this graph here, and there's probably other better graphs that could be used. This one I found just recently. So it was on Twitter, and this person has just mentioned there was some mathematical issues with this medal tally. So this was quite a number of weeks ago. So one thing to note with is when you're looking at the Olympics medal tallies, they always arrange it in order of your gold medals. So always it should be going from most gold medals to least, and that's the order that you go in. But the problem with this one, which isn't so obvious, is that these calculations haven't been done so well. So if you look at the adding of these numbers, China did get 49 medals altogether, so if you add that up. The USA actually has 54 medals, so someone hasn't done too well with their mathematics. Japan does have 30 medals. Australia actually has 31 medals. So if you just look at it on face value and you go, okay, here's the numbers, this is what's happened, then you've actually missed some information there. Now, I don't think they would have done this intentionally. I feel like it was just a bit of a calculator error or some sort of calculation error. But things like this is also important to be able to identify. I know earlier there was also a little bit of controversy in the US because rather than ordering their medal tally by the total of gold medals, they started ordering it by the total number of medals won. Now, if they order using the total medals won, obviously the USA is going to be right at the top. And so there was a little bit of controversy in the US because of that. And I think that particular media outlet had to go and apologize and rectify their medal tally after that as well. This last one, if you just look at it without reading through the fine print or the little words, it wouldn't really make too much sense to you. So right now the heading says Nurofen is better than paracetamol for common headaches. And there's this graph where you've got the paracetamols down the bottom and Nurofen's up the top. And it's sort of like, what does that mean? Like sometimes like when you're looking at this, if something's higher, then wouldn't that sort of mean that there's more pain? Like there's more of that item? So this can also be quite misleading here. On the side here, it's got patient relief rating. So I suppose it's saying how much maybe it means how much it's relieved the pain, like, how much your pain level has gone down by after taking Nurofen compared to a paracetamol. But there's not really any information about what this graph is meant to actually mean. So I think when we're looking at these sorts of graphs, sometimes like you might think, oh, this means better, but sometimes it could also mean it means it's going to be worse. So it's really important that you're reading carefully what's on each of the axes. When you're looking at an ad like this, you probably won't be reading these sorts of words. At the moment, I can barely even read that. So, like how much information can you really get from something like this? There is also a lot of fine prints there as well. So it's like, what would those fine prints be trying to tell us about Nurofen compared to a normal paracetamol, say for example? So here's just a couple of examples where maybe graphs and tables weren't used as well as they should have been, or you can see intentional and possibly unintentional misleading aspects of data. All right, we're going to get back into some of the theory. So just some terminology that we use commonly when we're looking at data. We talk about population. So population is basically a group of people with something in common. So normally we can talk about population as like, Australia's population. So every single person in Australia is part of the population. But what we can also do is when we're talking about a population is we can talk about a school being a population. So if I go and survey every single person inside of a school, then I've surveyed that population. So it's something in common. I could be choosing all of the students in year 10, and that could be my population because they're the ones that I want to ask a particular survey question to. So the population can change depending on who this survey or who's the target of this data collection. A census, so hopefully we're pretty aware of what a census is now. It's a survey where every item of the population is surveyed or examined. So our just recent national census, every single household had to fill in that survey. So the idea behind it is that every single person in the whole of Australia has been counted in some way or another. When we do things like school captain votes, we get all of year 12 to vote for it, so that would also be a census. So every single year 12 student had a vote in who would become our college captain. And so that would be another example of a census. A sample is a group chosen from the population to complete the survey. So we're not going to survey every single person, we're just going to pick out certain people or a group of people to complete this survey. So most of the surveys that you do online or if you get stopped on the street, that would be a sample. because they're not going to survey every single possible person. It's just going to be a certain number of people. It would be the same as if we were to conduct a survey at school, but we only invite the SRC to participate in the survey. So we've got a group of people who are chosen in order to complete the survey or be examined in some way or another. And then the last thing is we've got different types of statistical data. Now these terms are really important and you need to know what they are. So when we've got data, we can split this into two different types. We've got categorical data and we've got numerical data. So in the old language, making myself sound really old, categorical data was often called qualitative. Oh, I can't spell. Qualitative. And numerical was quantitative. Okay, so qualitative, quality means you're looking at some sort of category. Quantitative means quantity, which means numbers. So that's your numerical. So categorical data is usually given in words, whereas numerical data is given as numbers. Once we split into these two main umbrella branches, we can then split those further into more sections. So when we're looking at categorical data, we can separate that into nominal and ordinal data. So nominal data is where the categories have no order. So I think of it as nominal means names. Okay, so if I wanted to look at colors, okay, that would be a type of nominal data. Ordinal data is categories, so they're words, but we can order them in some way. So it could be months in the year. Okay, so it could be like if I was asking what is your birth month, we have an order for the months of the year. So that would be a type of ordinal data. Now, on the other side, we've got numerical data or your numbers. Numbers can also be split into two parts. So the first one, it's called discrete, and the other one is called continuous. Now, discrete data is data where we have distinct numerical values. Okay, so that means there's a separation between the numbers. So if I asked how many siblings you've got, that would be a type of discrete data because you can't have halves, you can't have quarters or anything like that. Shoe size would also be discrete data, okay, because you can wear a 4, you could wear a 4.5, a 5.5 and stuff. So you do have the halves, but you don't, it's not something that where, like, it's sort of like in clearly defined numbers that we can pick to use. So we can have the halves, but we won't go for we can't have quarters or eighths or other decimals. So we've got distinct numerical values, even though like for shoe size you could have halves. Continuous data, however, is data that can take any value within a given range. So if we're looking at temperature, we could round to 1 decimal place. We could have it to the nearest whole number. So depending on how well we measure it, how accurately we measure it, we can have any possible value we want. So usually when we're looking at continuous data, that's usually something that's measured. When we're looking at discrete data, it's usually something that's counted. So these are really important categories. Again, this sort of stuff will appear, like, you will see it quite a lot from here and also into senior studies. It's important that you know what each of those terms mean. I don't have any examples for today. So if you want to go and have a look at these questions, it's sort of based on all the things that we've been talking about in this video.